Welcome to this deep dive into Azure Functions. I've been working with serverless architectures for years, and Azure Functions has consistently proven to be a reliable ally in the cloud, offering true code-based scalability and ease of use that you just can't get at the traditional IaaS level. At its core, Azure Functions is essentially a way to run functions, which are small pieces of code that execute in response to events. These events can be anything from a timer trigger to HTTP webhook calls, and Functions lets you focus solely on the code itself, without getting tangled in the mundane aspects of starting and stopping servers, managing dependencies, or provisioning resources. Now, let me take you through an Azure Functions world, as I've experienced it in my day-to-day life, so you can understand the true potential and utility of leveraging this serverless paradigm in your own projects. Shall I start? Azure Functions provides a lightweight, .NET-based environment that you can run as stateless functions. But what's really slick about it is the way it scales. You write a function and then simply give it an amount of CPUs and memory to use. If your function becomes more popular and the demand increases, Azure Functions will spin up more instances to handle the requests and just as quickly scale back down when not needed. This means your function's footprint is predictable and you only pay for what you use, which not only saves costs but also simplifies billing. Let's say you want to create a function to process payments. Using Azure Functions, you'd write the logic once and be able to trigger it in response to a payment event without managing a dedicated payment service. And the beauty is, if the need arises, Azure scales it up automatically to ensure that the processing happens quickly, even during peak times, without you lifting a finger. The first step is to create an Azure Function app. You'll need to set up an Azure account, create a function app using the Azure portal or Azure CLI, and then define your function within that app. When you register a function, Azure gives you predefined bindings for various types of triggers and Azure services, which reduces the boilerplate code you need to write and helps prevent common configuration oversights. Speaking of boilerplate code, Azure Functions allow you to write the business logic in any language you like, though my personal preference leans towards C# due to its integration within the .NET ecosystem, as I've been using it for many years now. The function runtime is highly optimized to work with function as code, using packages and NuGet if you prefer C#. If I were helping you with a Java function, things wouldn't be much different, just with different bindings and a slightly different language experience. Once your function and app are configured, you can start enjoying real-time development and testing. Visual Studio Code with the Azure Functions extension is a great place to dabble with and debug functions directly from your development machine while watching the cloud in action. Advanced troubleshooting in Azure Functions is like finding a needle in a digital haystack compared to managing traditional infrastructure. Tools like Azure Monitor and Azure Log Analytics give you insights into function execution, performance, and errors. These insights allow you to quickly diagnose issues without worrying about server health or configurations going awry. They are simple yet powerful enough to ensure that your functions are reliable and efficient. When it comes to best practices for enterprise-level deployments, there's a lot to consider. First, always plan for horizontal scaling, as I've mentioned. That's a cornerstone of Azure Functions. Next, design with cold starts in mind. Cold starts can occasionally delay execution, so consider strategies to mitigate this, especially for latency-sensitive applications. You can use Azure's integration with Redis and other caching mechanisms to handle repeated, similar events more efficiently, reducing cold start impact. Moreover, security is paramount. Azure Functions apps come with many built-in security features such as HTTPS endpoints, shared access signatures, and integration with Azure Key Vault for managing secrets. Don't forget to leverage these to create a secure environment for your functions while simplifying the security management process. In my experience with serverless computing, there's one aspect that always strikes a chord with me: empowering developers with the freedom to code without the traditional infrastructure complexities. Azure Functions is a testament to how Microsoft embraces and advances this architectural movement. Whether it's a quick project or a SOF 0N0 or scale enterprise system, Azure Functions provides just the right balance of capability and simplicity that it takes a complex task, managing a vast infrastructure, and strips it down to pure, efficient code execution. In summary, Azure Functions is a powerhouse for serverless solutions. Whether you are implementing it for the first time or just want to enhance your current strategy, the benefits are clear. It's all about empowering your code, your team, and ultimately, yourself to focus on what matters, creating business value. And if you are ready to jump right in and see Azure Functions in action, remember, I have a comprehensive online resource, and I highly recommend visiting neeraj.dz on YouTube, where I regularly drop episodes with detailed guides and tutorials, including this very topic we've just covered. Don't forget to subscribe to the TechLab channel for more updates, insights, and tips on getting the most out of Azure and its myriad services. Visit TechLab, subscribe, and get the best from Microsoft in the cloud.